All right. Hello, hello. Welcome to tonight's free prep hour. My name is Jerry. I'm one of the instructors here at Manhattan Prep. And tonight, what I wanted to walk you all through are how to work on systems of equations. This is when we have more than one equation and more than one variable. And as we're going to find with these, there's more than one way of approaching them. So what we're going to do today is we're going to break down kind of the mechanics of how these work. And then we're going to look at them in increasingly more complicated contexts involving turning word problems into math, which is a really common place we see systems of equations like this. So before we get started, let me just hear from you all. Let me know in the chat where you're calling from and what your experience is with the GRE. Great, we have somebody coming pretty new, taking in place of the LSAT from Gaithersburg, Maryland. I don't think I've ever heard of Gaithersburg. Let's hear from a couple other folks. Where are you calling from? How much studying have you been doing? Have you taken a practice test? Anything like that? What's your experience? All right, cool. We've got somebody from Logan, Utah, who's taken a few practice tests, studied for about a month. Good. So it's okay if you're feeling a little shy here, but in a second, we're gonna start doing some questions together. And I would love it if you could send me your answers to those questions, just because it's not just about listening. You know, we may be doing some problems today where you may feel like, let me just kind of sit back and wait for the explanation on that. I would encourage you to just try it. Even if you mess up, you're going to learn more doing that than you are just kind of waiting for me to tell you how to do it. All right, we've got one more person from Miami, new to it as well. I've attended some workshops, but have not been consistent. Cool, excellent. So we've got people coming from all kinds of different background with the test. What we're looking at today is a pretty fundamental skill. Again, we're looking at systems of equations. And let's just kind of warm up. I've got like a really quick problem for you. This is kind of a sample system of equations problem we might see. And real quick, send me your answer to this when you've got it. Okay, I've gotten one answer. I'd love to see some more. Great. All right, cool. So, excellent, excellent. So, it's very tempting with this problem, and I was trying to tempt you into this mistake by saying it's really quick, really easy, right? There was kind of a trap that I was laying in that. That was an illustrative trap, which is it's very simple looking at this, and I fall for this too, and I teach this. I look at this and I'm like, all right, together they cost $1.10, bat costs $1 more. How much does the ball cost? the ball costs 10 cents. But that can't be, because if the ball is 10 cents and the bat is $1.10, that's too much. That's $1.20. So this is meant to be deceptive. The test won't necessarily try to deceive you in this way. But the lesson from this is, okay, if we see something like this going on, we need to be really deliberate about how we work it out. And so what we're going to work on today is, how do we turn this into a system of equations? And how do we solve that system of equations? So what do I mean by system of equations? Well, the tell here is that we have a baseball and a bat. We have two different things, which means we've got two different variables. And this could show up in a variety of ways where we have more than one variable. And the important thing is, when I see multiple variables, I need multiple equations. This is really, really important, because sometimes the test will try to disguise things and they'll give you one of the equations easy and you kind of have to figure out, like, wait, where's the other one going to come from? And that's important. So you need to know, as soon as you see you're dealing with two variables, you need to write both of those equations. So let's take a look at this, right? If we're going to call the ball X and the bat Y, together they cost $1.10. So the price of the ball plus the price of the bat equals $1.10. So my first sentence becomes my first equation. And the bat costs $1 more than the ball. Take this next phrase, the bat costs $1 more than the ball. In other words, if I add $1 to the ball, I get the bat. And if you're kind of like, where do I put that one? Does that one go on this side or this side? It's nice to test it with like a good, simple, common sense number first and be like, all right, you know, if the bat costs $2, the ball would cost $1. And if I put that in there, right, if I had this y equals 1 plus x, and I then put in my numbers, I'd see, like, yeah, that works. And I like to do that sometimes when I'm doing these, because like something like more than the ball, it's like, for me at least, I find it easy to like at least second guess myself. So it's good to do like a quick little check here. So once we have our system of equations, question is, how do we deal with it? We've got two different methods, which I'm going to run through quickly right here, and then slowly in a little bit. So the first method is substitution. We see the bat is 1 plus the ball. So let's go over here, and wherever we see y, let's substitute in 1 plus x. From here, we can solve it. Subtract 1 from both sides. Divide both sides by 2. Get x is 0.05. This method is more straightforward, but can take more time. And so I want to work with this first method a bit first before I introduce the second method, which is a little bit trickier to get the handle of, but it can be a lot quicker once you're good at it. So let's take a look at the substitution method a little bit more. So if I have these two equations, my system of equations with my two variables, and I'm asked to solve for y, this first way of doing it is substitution. What I want to do is isolate the variable I don't want. So I'm solving for y. Let me get x by itself. So I'm going to work over here because that x already doesn't have a coefficient on it. So I'll add 2y to both sides. Now I've got x all by its lonesome. And I can then plug in that value for x over here. Notice I'm not plugging it back into the same equation. That wouldn't accomplish anything for me. I need to plug from one equation into the other. That's important. So now I rewrite it, and it's good to, you know, until you're super, super good at these, even then. on the test, really good to be very clear with your scratch work about what's going on. It's so easy to make a mistake on something like this. Then I'm going to solve for y. So I'll distribute that 2. I'll combine my y's, subtract 6, divide by 7, and I solve for y. This is, again, I think the more straightforward way, the more kind of intuitive way. It's the way I certainly learned how to do these in like high school. The other way is sometimes a lot quicker, but it requires a little bit more finagling, let's say. And that's the elimination method. My goal is to eliminate the variable I don't want. And the way I'm going to do that is by either adding these equations together or subtracting them from one another. But what's important is I'm not just adding them or subtracting them to add or subtract them. I'm specifically doing so to eliminate the variable I don't want. So what that means in this case is I want to get rid of my x's. So what I'm going to do is I'm going to multiply this whole equation by a coefficient, -2. And now I've got -2x and +2x. So now when I add these two equations together, I stack them up and I add them together, those x's are going to cancel out and I get my y. So again, the point here is I'm trying to eliminate the variable I don't want. So I'm going to prep the whole equation by multiplying it by some coefficient, then add the equations together to cancel out that extra variable. If you get good at this, which I would suggest you do, these can become very, very quick. That said, part of the skill on systems of equations is recognizing which method is going to be easier in this case. That's going to depend person by person, but it's also going to depend case by case. So I'm going to give you 2 problems to try. I'd like you to send me your answers when you have them. And I want you to think about, for each one, which is the easier way to solve it. Okay. I'm going to stop you there. Send me your answers if you haven't already. So for this first one, if I'm thinking about which do I want to do, substitution or elimination, I notice I've already got X all alone. I think substitution is going to be the easier way here. So I'm going to plug in for Y, distribute that -2, add these together, divide by 2, or divide by 10, and get Y equals 2. I'm then going to take that Y equals 2, plug it back in up here to solve for X. So I plug from one equation into the other, solve for one variable, then take that number, plug it back into either equation, it doesn't matter, to solve for the other. In this case, plugging in here is going to be a little simpler. Over here, I could do substitution, but notice, oh, the question writers were kind of nice on this one, right? -5x and 5x, I actually don't have to do anything. I can just add these together, and those x's are going to cancel. Once I've got that y, I can plug it in to either equation and solve for x. Any questions about these? I want to just invite you, ask questions whenever you have them, either in the chat or in the Q&A function. I'm here to answer your questions. So let's try another one here. Another system of equations. Decide which way you want to do it. Send me your answers when you have them, please. All right, let's take a look at this. So if we use the substitution method here, we could solve either of these. In this case, let's solve for x. We get x is 2 plus y, plug that in over here. and then solve for y. 2 plus 2y is 8. Subtract the 2, divide by 2. Now we've solved for y. Plug that back in over here. X equals 5. Or we use elimination. And in this case, again, we don't have to change anything. We could eliminate either variable going in. Easiest to eliminate y since we already have positive y and negative y. So we just add these two together. Divide by 2, get x is 5. Plug that into either one of these and solve for y. Any questions or thoughts about this so far? Great. So I'm going to now start thinking about word problems. Because like I said, one of the places you're going to see these systems of equations is going to be in the context of word problems, like that ball and bat one that we started with. So just to kind of warm us up into that, I've got 3 little translation exercises for you to try. See if you can turn each of these phrases into equations, expressions, whatever they need to be. And send me them when you've got them. Okay. So sorry, seemed to be a little confusion in the chat. These actually aren't solvable. These are just a translation exercise. So if we see X and Y, we would need to be able to get some other equation from another sentence. This is just to practice the translation. So here, if we've got X is 4 less than y. I like to do a kind of direct translation and think x is 4 less than y. So that means y, if you decrease y by 4, you get what x is. That is tells me where to put the equal sign, which is helpful. Helpful to think about 4 less means subtraction. More means addition. If where x is 4 more than y, it'd be x is y plus 4. Helpful to know these and be able to not have to think so much about what's going on here. Aya is 6 years older than Shiv. So Aya is 6 years older than Shiv. Okay, so if we took Shiv's age and added 6 years, that's what we get for Aya. Again, this 6 years older or 6 years more than means it's on the is tells us where the equal sign, that older tells us we're adding there. Someone's asking in the chat, why does the y go after the minus or before? Good question, right? Because it's sort of confusing because it seems like 4 less than y. If you think about it this way, right? Like 6 is 2 less than 8. This is a sentence that's true, right? 6 is, if I did 2 less than 8, like that, that would give me -6. That's no good. So instead, we're thinking about it with this case that we really understand. If I'm doing 2 less than 8, or if I ask you, like, what's 2 less than 8? You'd count down from 8. So we subtract from the 8. You could think of like that than, less than means, yeah, good. So somebody's saying in the chat, is the word is equal to the equal sign? Yes, absolutely. So x is. And then over here, we can think of this whole side as like what's going on the other side. In this case, 4 less than y means subtract 4 from y. 6 more than Shiv, or 6 years older than Shiv, means s plus 6. There are half as many apples as bananas. Now here's a little more confusing, right? Because our is comes like before everything. So for this one, we're going to get this half as many apples as bananas. So another way of saying that is there's twice as many bananas as apples. So there's more bananas than apples. To make them equal, I would have to make the bananas less. Now let's check this, right? If there are half as many apples as bananas, maybe there's 2 apples and there's 4 bananas. If I put these numbers in there, do they work? Yes. This one I find kind of tricky personally. Maybe you've got an easier way to do it. Any questions about these? So this is one of the skills that we're going to be using now, as we now start to look at translations that lead into systems of equations. So I'd like you to try this. See if you can come up with the 2 equations and then solve them either by using substitution or elimination. Send me your answer when you have it. Okay, I'll stop you there. You can send me your answer if you haven't already. So here we've got two different sentences. And we know we need two equations because we've got these two different pieces. We'd call them X and Y. Somebody here was saying RL and RS, whatever notation works for you. But since we've got these two different pieces of different lengths, that's a clue that we're dealing with systems of equations here. We want two equations with two variables. So if our first one is just this first sentence, that the 40-foot rope is the short piece and the long piece added together. Our next equation is our next sentence is a new equation. One piece is 18 feet longer than the other. One piece is 18 feet longer than the other. So in this case, Y is our shorter side. And again, this is like that more than or less than, right? It's longer than the other, right? One piece is, that's our equal sign, 18 feet more than the other. Now, since we've already got this X isolated, it's probably easiest to just go ahead and substitute. So I'm substituting this value into this equation. Then I'm going to add my y's together, subtract 18 from both sides, divide both sides by 2, and that gets me my y. If I wanted to solve for x, I then could, and I realize which is the shorter one, the y. We could do this with elimination as well. Let me show you what that would look like. So I could take this equation here and subtract it from the other equation. I'm doing this because that's going to eliminate my y's for me. Oops. So when I do that, I get 40 minus x equals x plus y minus y, which is just those are going to cancel, plus 18. And I can solve it like this. Get my x's over to one side by adding x to both sides, subtract 18 from both sides. We're struggling with my oh, whoops, I made a mistake here. This should be minus 18. It's like, why did that come out wrong? So I add 18 to both sides. Excuse me, been a long day. 26 equals x. And then I could plug that in up here. Is y plus 18. Subtract 18 from both sides and end up getting, wow, I have no mental math today, you guys. It's not in me. Well, I'm getting 8. That's not right. Oh, because 58 divided by 2 is not 26. Oh my goodness. Ah, and this is being recorded, you know? Just goes to show you, helpful to use the calculator. So 29, there we go. And now we get 11 equals y. So that would be the other way to do it. I think this is a little less intuitive in this problem to my eye, but whichever way feels good to you. So let's try another one. See again if you can write the two equations and then solve them, either using substitution or elimination. All right. So if we've got 4 more women than men, so if we've got M and W, and I find with these, it's really helpful to start out by writing what my goal is. So they're asking me for the number of women, so I write that on my page, put a box around it, because there's been too many times that I've solved for the wrong thing. So there are 4 more women than men. So that means if you thinking about this qualitatively, there are more women than men, so to make them equal, I'd have to add to the men to make them equal. And there are 10 members on the board. How many are women? So in this case, let's try using elimination. I'm going to subtract this equation here. Why am I doing that? Just because I see I've got M, and I can subtract and end up canceling those out. So I get W minus 4 equals 10 minus W. Add W to both sides. Add 4 to both sides. W equals 7. Now, I could also do this with elimination or substitution instead. Call it M equals 10 minus W, and then plug that into this other equation. Call it 10 minus W plus 4 equals W. So we get 14 minus W equals W. 14 equals 2W. 7 equals W. I don't know which is easier in this case. It's kind of dealer's choice, I'd say. But again, you want to be good at both of these so that you can choose the one that's going to be easiest for you. All right, let's try another. Send me your answer when you've got it. Okay, send me your answer if you haven't already. Oops. So we've got a total of 12 apples and pears. And she bought 2 more apples than pears. So there's more apples than pears, which means we got to add to the pears to make them equal. We're looking for the pears. We've already got a nice substitution set up right here. Combine our terms. Subtract 2 from both sides. Divide by 2. And we get choice B. All right. Let's try upping the difficulty a little bit here. All right. So we've got apples and we've got pears. Jorge buys 4 apples and 4 pears for $3.20. Gina buys 6 apples and 2 pears for $2.40. Now pay attention to what we're looking for. How much more than an apple does a pear cost at market? So we're looking for the difference in price. And this is pretty important, as we're going to see. Oops, I forgot to put in the variables here. So already we see not necessarily an easy substitution to do. So let's try elimination here. I'm noticing I've got 2p and 4p. So I'm going to multiply this whole thing by -2. Why did I do that? Because now I've got -4p, +4p. Line them up, and let's add these together. When I do that, I get -8a equals -1.6. And you may be worried at this point. You're like, wait a second, why I shouldn't want negative things. But notice we've got the negative on both sides. So that's going to cancel out. Divide both sides by -8. We get a equals 0.2. And I may at this point say, great, I'm done. But if I do, I've just fallen for their trap. Because remember, my goal is not the price of an apple. My goal is the difference in price. So I've now got to take this, plug it into either of these two, and solve for p. This is clearer, so let's just solve it. Put it over here. Subtract 1.2 from both sides. Divide both sides by 2. We get p equals 0.6, which let's realize is also another trap answer. They really want you to do all this work and then be like, cool, let me miss it at the very end. So instead, we're like, oh no, I'm smart. I wrote down what I'm looking for to start with. I get the difference in price is 0.4, and that's my actual answer. Any questions or thoughts about this? So far, we've been dealing with systems of equations. In our last couple of minutes, I want to take a look at one other thing we might see, which is systems with inequalities. Now here I've got an equation and an inequality. They're asking me about the value of y. I can always plug from an equation into an inequality. I can never do the reverse. Let's think about why. So if I wanted to substitute here, I can isolate x, plug 2 plus y in for x over here, and that teaches me about y. I couldn't do the opposite, because let's say I want to plug in for x, and I say, all right, cool, x is greater than 7, so x is 8. And I plug 8 equals 2 plus y. Let's do that. Let's just look at it, right? 8 equals 2 plus y. So that means 6 equals y. All right, cool. But let me pick another number that's bigger than 7. 100. 98 equals y? Y can't be equal to both of these things. Because I'm given a range here, I'm not given an actual value for x, I can't actually do this substitution. This is not allowed. But I can substitute from an equation into an inequality. What that means is, if I have multiple inequalities, I can't substitute. Instead, I'm going to stack and add. I need to make sure my signs are pointing in the same direction. If they're not, I need to turn one around, either by multiplying it by -1 or by just flipping it, right? So if 2x minus y is greater than 9, I could say 9 is less than 2x minus y, for instance. Once I have my signs pointing the same direction, I can add them together. I don't want to subtract. because that would flip the sign. You may recall, or maybe just learning, that if you multiply or divide an inequality by a negative number, it flips that inequality sign. We don't want to do that. We went through all that effort to line them up. So instead, we're always going to add. And in this case, doing that is going to help us solve for x completely. So I've got one last problem for you. We're going to try this, and then I'm going to be, I'll stick around for a bit to take questions about the test in general. If somebody's asking, if you want to flip it, you subtract. You could. That feels like a dangerous to me. I usually like to do this method of just kind of turn it around. The other way you could do it would be to multiply it by a negative, but multiply it by -1. So call it like minus 2x plus y is less than -9. That would also flip it around. I think this is a little easier, honestly. This, it's easy to make a mistake with. But if I do either of these, I'm still not going to subtract. Okay, let's try one last question here. This is a QC, quantitative comparison question. You may or may not be familiar with these. The answer choices here, we're trying to pick the bigger side. We pick C if they're equal, and D if it can't be determined. So send me your answer when you have it. Okay, so because I have a system of inequalities here, I need to add them together. But notice these signs are facing opposite directions. So I'm going to take this second one and turn it around. So now they're facing the same way. Now I'm going to add them together. So I get 3a plus b is greater than 7 plus b plus 2. Just clean that up a little bit. And now I'm going to subtract b from both sides. And somebody was asking me about this in the chat, about clarifying what did I mean by don't subtract. This kind of move is totally okay. I can always add or subtract anything from both sides. I can even multiply both sides by the same thing. When I'm just solving an inequality, really anything goes. Just keep in mind, if you if you multiply or divide by a negative number, you have to flip the inequality sign. So that's why I was saying don't subtract the inequalities from each other. Because if I did that here, that would mean I'd also have to flip this sign. It just gets too confusing. Just stay away from it. So you always want to add the inequalities together. Once you've got your joint inequality, do whatever you want to solve it. So, okay, let's subtract b from both sides. And then divide both sides by 3. And I see a is greater than 3, which tells me quantity a has to be bigger than quantity b. So again, if we recognize the kind of problem we're dealing with, see that I've got more than one variable and more than one, in this case, inequality, that's going to tell me how to do it. So, any questions about this before I wrap up? Okay. So, when I see multiple variables, I know I'm going to need multiple equations. When I'm solving a system of equations, I can either substitute, where I solve for one variable, plug into the other equation, or eliminate, where I'm going to add the equations together to eliminate a variable. Usually, you have to multiply an entire equation by a coefficient first. When I've got a system with inequalities, I can substitute from an equation into an inequality. If I've got two inequalities and two variables, don't substitute. Instead, I'm going to add them together. Or let's clarify that. Line up the inequality signs and add them together. And that's also just mark. Don't subtract them. That would flip the sign. So I hope this was a helpful hour of practice on this fundamental skill. We started getting into working with word problems. I would also say that kind of translation skill that we worked on a little bit today is one of the really important fundamental skills to keep practicing for the GRE. If you're able to quickly read a word problem and turn those words into math, and then you're able to quickly deal with that math, you're going to be on your way to a great score. All right, so I'm getting a question to go over the inequalities. Yeah, Clarion, can you specify your question? What about it do you want to see again? I'll go back to my explanation slide on that. So here I've got an equation and an inequality. Yeah, this will be posted on YouTube. I don't know exactly how soon, probably like next week or something. So here I've got an equation and an inequality. And I can substitute from the equation into the inequality, but not the other way around. With multiple inequalities, I'm going to add them together, line up the sign and add them together. Does that clarify things at all, Clarion? Great. All right. Well, I'm now going to turn off the recording, and then I'm happy to take some, so any other questions about the content here, and then I'll turn off the recording, and I'm happy to take a little bit of time to answer any other questions about the GRE that you might have. Great, thanks, Ashley. I'm glad it was helpful. Okay, so I'm gonna stop recording if I can figure out how. There we go.